November 19, 1944, a snow-dusted field outside Eschweiler, Germany. 3 Luftwaffe mechanics stood beside a peculiar American vehicle they had just dragged from an abandoned Allied position. The machine was unlike anything in their own inventory. Half truck, half tank. It sat low and squat on a combination of front wheels and rear tracks, painted in the now familiar olive drab that marked every piece of American equipment flooding into Europe. Obergefreiter Klaus Hoffman, a veteran mechanic who had serviced everything from Messerschmitt fighters to Opel Blitz trucks, walked slowly around the vehicle. He had been told to evaluate this captured half-track for possible use by German forces. What he discovered in the hours that followed would shake his understanding of industrial warfare more profoundly than any encounter with an enemy fighter plane ever had. This was not a story about superior firepower or revolutionary technology. This was about something far more devastating to German military thinking: the systematic, almost boring reliability of American mass production. The M3 half-track personnel carrier, bearing serial number USA 401228847, would become a window into a truth the German High Command had refused to accept. America was winning the war not through brilliance or innovation, but through the crushing, relentless power of an industrial system that simply never stopped working. The Wehrmacht had entered the Second World War convinced of its technological supremacy. This confidence was not unfounded propaganda. It was rooted in a deeply ingrained national philosophy. German engineering represented the pinnacle of precision manufacturing. The Tiger tank with its 88mm gun, the MG-42 machine gun capable of 1,200 rounds per minute, the V-2 rocket, a weapon from science fiction made real. These were not just military tools, they were monuments to German technical genius. At the heart of this philosophy lay a fundamental belief that quality would always triumph over quantity, that a smaller number of superior machines operated by well-trained soldiers could defeat any mass of inferior equipment. This thinking permeated every level of German military production, from the smallest bolt to the largest battleship. The German approach to mechanized transport reflected this mindset perfectly. When the Wehrmacht recognized the need for armored troop carriers, they created the Sd.Kfz 251, a marvel of engineering complexity. Designed by Hanomag and produced in 17 distinct variants, it featured sophisticated armor arrangement, precise welding techniques, and intricate mechanical systems. Each vehicle required approximately 6,000 hours of skilled labor to construct. The production process demanded specialized tooling, highly trained workers, and an unbroken supply chain of precision manufactured components. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. On paper, the Sd.Kfz 251 was magnificent. In practice, it represented everything wrong with German industrial warfare. By November 1944, Germany had managed to produce approximately 16,000 of these half-tracks across all variants since 1939. This seemed impressive until compared against American production. In that same period, The United States had manufactured over 41,000 M2 and M3 half-tracks, not 17 variants requiring different parts and training. 2 main models with interchangeable components. The mathematics of this disparity revealed the fundamental flaw in German thinking. It was not that German engineers lacked skill or knowledge. They possessed both in abundance. The problem was philosophical. They built machines to be perfect rather than machines to be built. Every Sd.Kfz 251 that rolled off the production line was indeed a superior vehicle in many technical respects. But superior meant nothing if you could not produce enough of them to equip your armies. By late 1944, the Wehrmacht was fighting a war across multiple fronts, stretching from France to the gates of Moscow. They needed tens of thousands of reliable transport vehicles immediately. What they had instead was a collection of technical masterpieces that took too long to build, required too many specialized parts, and were too complex to maintain in field conditions. This was the industrial reality that Klaus Hoffman and his fellow mechanics were about to confront when they opened the engine compartment of that captured American half-track. Inside they would find not German precision, but something far more dangerous, American pragmatism operating at a scale Germany could never match. The M3 half-track sitting in that field near Eschweiler represented a completely different philosophy of industrial warfare. Its design history revealed the divergence in thinking that would ultimately decide the conflict. In 1940, the United States Army Ordnance Department approached the White Motor Company with a requirement for an armored personnel carrier. The specifications were brutally simple. It must carry 13 men. It must be reliable. It must be producible in large quantities using existing automotive manufacturing infrastructure. What the Army did not demand was perfection. They did not require sophisticated armor schemes or complex mechanical systems. They wanted a truck that worked and could be built by the thousands. White Motor Company, an experienced manufacturer of commercial trucks, approached the problem like truck builders rather than military theorists. They started with proven components from their civilian product line. The engine, transmission, and front axle were taken directly from White's commercial truck catalog. These were parts already in mass production, with established supply chains and trained mechanics who understood how to maintain them. The innovative element, the tracked rear suspension, came from a design White had already developed for half-track artillery tractors. By combining existing proven components, rather than engineering everything from scratch, White created a vehicle that could be manufactured using conventional truck building techniques. This meant any factory capable of building trucks could potentially build M3 half-tracks. Not just specialized armament works, but civilian automotive plants across America. The first production M3S rolled out in 1941. By 1942, multiple manufacturers were producing them. White Motor Company, Autocar Company, and Diamond T Motor Company all built identical vehicles using the same blueprints and interchangeable parts. This standardization, this absolute commitment to making every component identical and replaceable, was the key to American industrial dominance. A destroyed M3 half-track in North Africa could have its engine replaced with one shipped from a factory in Detroit. The transmission from a damaged vehicle in Italy could be installed in another half-track in France. Every component was catalogued, stockpiled, and distributed through a logistics system designed from the ground up to support mass-produced equipment. When Hoffman and his mechanics began their detailed examination of the captured American half-track, they started with the engine compartment. What they found was almost insultingly simple. The white 160AX inline six-cylinder engine displaced 455 cubic inches and produced 147 horsepower. By German standards, this was crude. The engine used a simple L-head valve configuration rather than the more efficient overhead valve design German engineers preferred. The carburetor was a basic single-barrel unit. The ignition system used conventional distributor and coil technology that was already considered outdated in German automotive circles. But as Hoffman and his team disassembled and examined each component, they began to understand the brilliance hidden in this apparent crudity. Every part was overbuilt. Design margins were enormous. Where a German engineer might calculate the precise minimum thickness required for a component and build to that specification, American engineers appeared to have simply made everything substantially heavier and stronger than necessary. This created an engine that was less efficient in terms of power-to-weight ratio, but far more tolerant of battlefield conditions, inadequate maintenance, and operator error. The transmission revealed the same philosophy. It was a 4-speed manual transmission, a straightforward design that any truck mechanic could understand and repair. The gear ratios were not optimized for maximum performance. They were optimized for reliability and ease of operation. The clutch was heavily sprung and nearly impossible to burn out even with abuse. The synchronizers, though simple, were robust enough to function reliably even when worn. This was a transmission designed for soldiers who might have minimal training, operating under combat stress, in vehicles that might go weeks or months without proper service. The Germans had designed their transmissions for skilled operators who would follow proper procedures. The Americans had designed theirs for reality. The track and suspension system demonstrated American pragmatism at its finest. The front wheels were standard truck components. The rear track system used a simple volute spring suspension that any mechanic could understand and maintain. The tracks themselves were made of rubber and steel, replaceable in sections rather than requiring complete replacement of the entire track assembly. The German Sd.Kfz 251 used a complex torsion bar suspension system that provided superior ride quality and handling. But torsion bars required precision manufacturing and skilled installation. If damaged, they often required the vehicle to be returned to depot-level maintenance facilities for repair. The American volute spring system was crude by comparison. It gave a rougher ride. It was less sophisticated mechanically, but it could be repaired by any competent mechanic with basic tools. Springs could be replaced in field conditions in less than an hour. This was the pattern repeated throughout the vehicle. Where German engineering sought optimization, American engineering sought reliability. Where German designs required precision, American designs used brute strength and generous tolerances. Where German vehicles were masterpieces of mechanical art, American vehicles were tools built to do a job and keep doing it regardless of conditions. Hoffman's report to his superiors, archived now in the Bundesarchiv, captured his growing unease. "The American half-track is mechanically unsophisticated," he wrote, "but this simplicity is deliberate. Every component is designed for replacement and repair under field conditions. The vehicle requires minimal specialized training to operate and maintain. Most critically, all components appear to be standardized across their entire fleet." This last observation was what truly disturbed German logistics officers who read the report. The Americans were not just building vehicles. They were building a system. Every M3 half-track in Europe, North Africa, and the Pacific used identical parts. A mechanic trained on one vehicle could service any other. A warehouse in England stocking M3 components could support half-tracks operating anywhere in the European theatre. Supply officers could track and distribute parts using a unified system rather than managing hundreds of unique component streams. The contrast with German practice was stark and damning. By late 1944, the Wehrmacht operated dozens of different half-track variants, each requiring its own parts inventory. The Sd.Kfz 250 series, the lighter cousin of the 251, shared almost no components with its larger brother, despite similar function. The Sd.Kfz-7, an 8-ton half-track used for towing artillery, was an entirely different vehicle built by different manufacturers using different parts. This fragmentation meant that a repair depot needed to stock thousands of unique components to support the various half-tracks in service. A mechanic trained on one variant often lacked the specialized knowledge to properly service another. Supply officers faced a logistical nightmare, trying to ensure the right parts reached the right units. And as Allied bombing intensified and German transportation networks collapsed, this complexity became catastrophic. The captured M3 was put through field trials that would reveal the full extent of American industrial advantage. Hoffman and a small crew drove the half-track over rough terrain, through mud, across frozen ground. They operated it for hours without maintenance. They deliberately abused it, pushing the engine hard, grinding gears, overloading the cargo bed with equipment and personnel. The vehicle simply continued to function. After 3 days of hard use, they performed their first maintenance inspection. What they found astonished them. The engine showed minimal wear. Oil consumption was low. The transmission operated smoothly. The tracks remained properly tensioned. Most critically, nothing had broken. Not a single component had failed or required replacement. This was unthinkable in German experience. The Sd.Kfz 251, for all its technical sophistication, required constant attention. Experienced crews knew to check track tension daily. The complex bogie wheels needed regular lubrication. The transmission demanded careful operation and frequent fluid changes. A typical German half-track might operate reliably for a few days before requiring some form of maintenance intervention. The American vehicle had run hard for 3 days, and asked for nothing but Kunststoff, fuel. Hoffman's second report went beyond mere technical description. He had begun to understand what this vehicle represented. "The Americans have not built a superior half-track," he wrote. "They have built an adequate half-track that they can produce in enormous quantities and maintain with minimal expertise. This represents a fundamental difference in industrial philosophy that we cannot match." His superiors, reading this report at Luftwaffe Logistics Command, understood the implications immediately. Germany had spent the war trying to win through technical excellence. America was winning through industrial scale, and it was too late for Germany to change course. The full scale of American half-track production became clear through captured documents and intelligence reports that reached German high command throughout 1944. The numbers were almost impossible to believe. By the end of the war, American factories would produce over 41,000 M2 and M3 half-tracks. This was more than double Germany's total production of all half-track variants combined, but the disparity was even worse than raw numbers suggested. American half-tracks were organized into a unified logistics system with standardized parts, training, and maintenance procedures. German half-tracks were scattered across multiple supply chains, each requiring specialized support. An American armored infantry battalion could expect rapid parts delivery and straightforward repairs. A German Panzer Grenadier battalion struggled to keep their vehicles operational as supply lines stretched and specialized components became unavailable. The strategic implications were devastating. The half-track was not a weapon system that would win battles directly. It was a logistics multiplier. It moved infantry rapidly to keep pace with tank advances. It carried supplies forward to frontline units. It evacuated wounded from the battlefield. It served as a mobile command post, a mortar carrier, an anti-aircraft platform, and a dozen other roles. Every additional half-track in service increased an army's operational tempo and flexibility. The Americans had 41,000 of them, all using the same parts, all maintainable by any trained mechanic. The Germans had fewer than 16,000 across multiple incompatible types, each demanding specialized support that their collapsing logistics system could no longer provide. This disparity manifested most clearly in the Battle of the Bulge, which was raging even as Hoffman examined his captured M3 near Eschweiler. German forces in the Ardennes offensive had achieved tactical surprise and early success. But within days, their advance stalled not primarily from American resistance, but from their own logistical limitations. German mechanized units outran their supply lines. Vehicles broke down and could not be repaired in field conditions. Fuel trucks could not keep pace with advancing armor. Meanwhile, American forces, after their initial shock, responded with a speed and flexibility that German commanders found incomprehensible. Entire divisions reoriented and moved hundreds of kilometers in days. Supply lines stretched to accommodate these movements without collapsing. Half-tracks carried infantry forward to establish new defensive positions. When vehicles broke down, they were quickly repaired or replaced from seemingly inexhaustible stockpiles. German officers, accustomed to carefully planned operations constrained by logistics, could not understand how American forces moved so freely. The answer lay not in superior American leadership or tactical doctrine, it lay in vehicles like the M3 half-track. Simple, reliable, produced in overwhelming numbers, and supported by a logistics system designed from the beginning to operate at continental scale. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The captured M3 near Eschweiler became a teaching tool for Luftwaffe mechanics and logistics officers. It was driven to various German units so personnel could examine it firsthand. Each group that studied the vehicle came to the same conclusion. The Americans had won the Industrial War years ago. Germany was now simply fighting with the weapons and equipment it could scrape together from a broken production system, while facing an enemy whose industrial machine had barely begun to strain. Post-war interviews with German industrial leaders and military logistics officers revealed the depth of their miscalculation. Albert Speer, Reich Minister for Armaments and War Production, admitted in his memoirs that German industry had never understood the fundamental requirements of industrial total war. They had optimized for quality when they should have optimized for quantity and reliability. They had pursued technical perfection when they should have pursued production efficiency. The American approach, which German engineers had initially dismissed as crude and unsophisticated, proved vastly superior for the realities of global mechanized warfare. A vehicle that was merely adequate but available in unlimited numbers with guaranteed parts supply was infinitely more valuable than a technically superior vehicle that was scarce and difficult to maintain. This lesson, learned too late by German forces in the field, would fundamentally reshape post-war military-industrial thinking. The German military that emerged in West Germany after 1949 incorporated American industrial principles into its equipment development. The Bundeswehr, when it began to rearm in the 1950s, consciously rejected the over-engineering that had characterized Wehrmacht equipment. They studied American logistics systems and parts standardization. They emphasized reliability and maintainability in their procurement specifications. The result was equipment like the HS-30 infantry fighting vehicle, and later the Marder, which, while technically sophisticated, were designed from the start for mass production and field maintenance. German post-war military industry had learned through bitter defeat what American industry had known from the beginning. That sustained military operations at scale required weapons designed for the logistics system rather than logistics systems built around weapons. The M3 half-track itself served with American forces through the end of World War II and beyond. Many were transferred to Allied nations under Lend-Lease and military aid programs. Israel used them extensively, modifying them for desert warfare. They appeared in the Korean War, still reliable, still functional, still doing the unglamorous work of moving soldiers and supplies that wins wars. The last American M3 half-tracks were not retired from military service until the 1980s. Vehicles designed in 1940 and built for World War II were still operating reliably 4 decades later. This operational longevity was the ultimate validation of the American design philosophy. Build it simple, build it strong, build it to last, and build enough of them that the enemy drowns in the sheer scale of your industrial output. Klaus Hoffman survived the war. In post-war interviews, he spoke candidly about his experience examining the captured American half-track. "We knew by then that we were losing," he said, "but understanding why we were losing was different. When I saw how that American vehicle was designed and built, I understood that we had been defeated not by better soldiers or superior tactics, but by a system of production we could never match. They had built an industrial machine that turned out weapons faster than we could destroy them, and every weapon they built was designed to work reliably with minimal support. We had built masterpieces. They had built tools. In war, tools win." This admission captured the essential truth revealed by the M3, half-track, and the entire American arsenal. The Second World War was not won by any single weapon system or brilliant strategy. It was won by the industrial capacity to produce reliable equipment at a scale that overwhelmed enemy forces through sheer material superiority. The half-track, like the Sherman tank, the Jeep, the Liberty ship, and countless other American weapons, was not individually exceptional. What made it exceptional was that America built 41,000 of them, supported each one with a comprehensive logistics system, and designed them so that any mechanic with basic training could keep them running under combat conditions. This was the revolution in warfare that German military thinking had failed to anticipate or counter. Not a revolution in tactics or technology, but a revolution in industrial organization and production philosophy. The mathematics were brutal and unforgiving. By 1944, the United States was producing more military equipment in a single month than Germany could produce in a quarter. American factories operated with 3 shifts around the clock, fed by natural resources from across North America, protected from enemy bombing by 2 oceans. German factories struggled under Allied bombing, starved for raw materials, hampered by sabotage and insufficient skilled labor. Every American half-track that rolled off a production line represented steel, aluminum, rubber, and labor hours that America could easily afford. Every German half-track required materials and labor hours that Germany desperately needed for a dozen other critical production programs. The Americans could lose 1,000 half-tracks and replace them within weeks. Germany could not afford to lose 100. This disparity extended across every category of military equipment. American aircraft production exceeded German and Japanese production combined. American ship construction allowed the replacement of convoy losses while simultaneously building the largest fleet in history. American small arms production equipped not just American forces, but British, Soviet, and Free French armies as well. The half-track was simply one visible symbol of this overwhelming industrial dominance. When German soldiers saw American half-tracks moving infantry forward, they were witnessing the physical manifestation of an industrial system they could not defeat. Behind each vehicle stood factories working continuously, ore mines operating at full capacity, rail networks moving materials efficiently, training schools producing mechanics, and supply depots stockpiling parts. The vehicle itself was almost incidental. What mattered was the system that produced it, maintained it, and replaced it when necessary. Germany had better engineers. They designed more sophisticated weapons. They achieved remarkable innovations under desperate circumstances. But they lacked the industrial depth and organizational efficiency to compete with American production operating at full capacity. The captured M3 half-track sitting in that field near Eschweiler in November 1944 was a herald of defeat. Klaus Hoffman and his fellow mechanics understood this immediately when they examined its simple, robust construction. Their superiors understood it when they read the reports and compared American production numbers to their own dwindling output. German soldiers understood it when they faced American units that seemed to have unlimited supplies of fuel, ammunition, and equipment. The war would continue for 6 more months. Germany would fight with desperate determination and tactical skill. But the outcome was inevitable from the moment American industrial capacity reached full mobilization. The M3 half-track and vehicles like it represented the inexorable tide of production that would ultimately bury German forces under sheer material weight. There is a photograph in the Imperial War Museum archives taken in April 1945 near the Elbe River. It shows American and Soviet forces meeting for the first time. In the foreground sit multiple M3 half-tracks, still operational after crossing Europe. Their crews stand beside them, relaxed, confident. The vehicles behind them are battered but functional, exactly as designed. They had carried soldiers through North Africa, Italy, France, and into Germany itself. They would continue to carry soldiers for decades after the war ended. This was not the weapon that captured the imagination, not the tank or the fighter plane that inspired movies and myths, but it was the weapon that won the war. Not through firepower or technical brilliance, but through the simple, devastating fact of its existence in quantities the enemy could never match. The Americans had not just built a better half-track, they had built a system of production and logistics so efficient, so scaled, so thoroughly designed for sustained global warfare, that the outcome was never in doubt once it reached full operation. Klaus Hoffman's captured M3 was eventually lost to history. Whether it was destroyed, abandoned, or reclaimed by American forces is not recorded, but its legacy lived on in the minds of every German soldier and officer who witnessed American material superiority firsthand. They had entered the war believing in technical excellence. They ended it understanding that modern industrial warfare demanded something more fundamental: the capacity to produce adequate weapons in overwhelming quantities, support them with comprehensive logistics, and design them for reliability rather than perfection. This was the lesson America taught through vehicles like the M3 half-track, a lesson purchased at great cost in lives and resources, but one that fundamentally reshaped military thinking for the remainder of the 20th century and beyond. The humble half-track, neither fully truck nor fully tank, represented the hybrid philosophy that won World War II. Pragmatic rather than perfectionist. Reliable rather than revolutionary. Producible in the quantities war demanded rather than in the limited numbers that engineering pride could justify. In the end, That philosophy proved more powerful than any individual weapon, any tactical innovation, or any amount of technical sophistication. The war was won by the nation that understood this truth first, and applied it most comprehensively.